Here we are in section 4.1, exercises 10 through 18. It says solve each system of equations by elimination. That means we're going to multiply one of the equations or both of the equations or none of the equations so that when we add them together, one of the variables disappears and we will be able to solve it for one variable. So number 10, let's look at what we have. 2x minus 3y equals 6, 5x plus 3y equals 22. These two are already set up for elimination. If we add the two equations together, we get 7x, y's are gone, equals 6 plus 22 is 28. That gives us that x equals a 4. Well, all right, so x equals a 4. That means we stick it back in either one of them because we better get the point that has both of them in it. So stick x is 4 back up there, and we get 2 times 4 minus 3y equals 6. That's 8 minus 3y equals 6. Subtract 8, we get negative 3y equals negative 2. Divide by a negative 3, and we get y equals a negative, we get a positive 2/3. So we end up with 4 2/3. And we could check that in this other equation to make sure it works there. 20 plus 3 times 2/3, 20 plus 2 equals 22, and it works. So that one is indeed our answer. All right, let's try it with number 11. Now in this one, if we add these, we get 8x and we get a minus y. So we don't eliminate a variable. So we're going to times the top one by 2 everywhere. So this is 6x plus 2y equals a negative 4. Notice I times everything by a 2. And now look what we have. We now have, oh, look at this. Add those together and we get 11x. Those go away equals negative 33. Divide by 11, we get x equals a negative 3. You'll notice these are the same problems that were in the previous section, and we're just getting the same answers by a different method. So let's take this guy right here, this negative 3, and stick him in somewhere like that. So we now have 5 times a negative 3. So 5 times a negative 3 minus 2y equals negative 29. This is negative 15. So let's go ahead and write it out. Negative 15 minus 2y equals negative 29. Add 15 over, you get negative 2y equals a negative 14. So y equals 7. That's negative 3, 7. And you can check and make sure that that works up in the original equation as well. 3 times a negative 3 is negative 9 plus 2 times 7. Oh, without the 2. 3 times a negative 3 is negative 9 plus 7 is negative 2. And it works just like, oh, wow, clockwork. I like it. All right, so the next one. We now are 4x plus 7y equals 2, 3x minus y equals 14. What's the easiest thing we could do to get one of these to cancel? Well, times the bottom one by 7. So if we times the bottom one by 7, we now have a 21x minus a 7y equals 98. Times by 7, times by 7, times by 7. And look at what we've created. This system of equations, where now when we add these together, we get 25x over here, gone, equals 100. Divide by 25 and we get x equals 4. And we take that, x equals 4, and take this guy and put him right back up there, and we get 4 times 4 plus 7y equals 2. That's a 16. Subtract 16 from both sides and we get 7y equals a negative 14. Divide by 7, we get y equals a negative 2. And does that really work? 4 negative 2? Yes, indeed it does. You can stick it into the upper one or into the bottom one, and you get that it works. Okay, next one, number 13. 4x plus 3y equals 7. 8x plus 6y equals 14. What would be the easiest thing is to multiply this by something that'll cancel either the x's or the y's. Let's focus on the y's. Let's multiply through by a negative 2. So we get negative 8x minus 6y equals negative 14. Uh-oh. Look what happens when we now add all those. 0, 0 equals 0. That means we have infinite solutions. These are the same line. They're always crossing. So these two lines actually are the same line. We could tell one of them was just times by 2 of the other one. That's amazing. So they are exactly the same line. They're always crossing. Every time 0 equals 0, which is always. All right, next one, number 14. Very similar, it looks like. 4x plus 3y equals 7, 8x plus 6y equals 15. So if we times the top again by a negative 2, we get negative 8 minus 6, negative 14. Add those together, and we now have 0 equals 1. 0 equals 1. That never happens. That means that these two lines, they're parallel. We can see that the slopes, negative 4/3, negative 4/3, but they go through different points. That means they're parallel or no solution. That means this is an inconsistent system of equations. It has no answer. You could also write parallel lines, parallel. There we go. All right, number 15. 3x plus 3y equals 7, 7x minus 6y equals negative 14. Could we multiply either the top or the bottom by something that would allow us to eliminate? Yeah, look at that. If we times the top one by 2, this will become a 6 and they'll go away. So times by 2 and we get a 6, 6, and a 14. So when we add them, we have 13x, no y's, and equals 0. Divide by 13, divide by 13, and we get x equals a 0. Now notice that's not the same as 0 equals 0 or 0 equals 1. That is, x is actually 0. That means we have 0 something. So if we go back through and stick in 0 for x, we get 7 times 0. Let's stick it right in there. 7 times 0 minus 6y equals 14. So that's gone. Divide by a negative 6 and we get y equals negative 14 over negative 6. And that is positive 7/3. Y is 7/3. And you could check that and see if it works in both equations. 0, 7/3, yep, and it works, giving us that in the first equation as well. All right, number 16. 6x minus 5y equals 3, x minus 2y equals negative 3. Is there a, we could either times the top by a 2 and a 5 to get rid of the y's, or, we could times the bottom by a negative 6. Let's write them both out and times the bottom one by a negative 6. 6x minus 5y equals 3. And timesing this bottom one by negative 6 is negative 6x plus 12y equals positive 18. Times by negative 6, negative 6, and negative 6. Okay, so when we add them, we now have 7y equals 21. Divide by 7, we get y equals 3. So now we're going to substitute that y equals 3 straight up into one of these. Doesn't matter which one. Should give us the same answer. So now we have x minus 2 times 3 equals a negative 3. So x minus 6 equals a negative 3. Add 6 to both sides and we get x equals 3. What? 3, 3, does it really work in both of them? 3 minus 6 is negative 3, yes. 18 minus 15, when we stick them both in, does indeed equal 3. Look at that. Great. All right, now we have number 17. Negative 2x plus 3y equals 16, and 3x minus y equals 17. We can either times the top by 3 and the bottom by 2, and that would allow the x's to cancel, or we could times the bottom by 3. I think the bottom by 3 looks a little bit easier. So let's write it both out. Negative 2x plus 3y equals a negative 16. And 3x minus y timesing all by 3 is 9x minus 3y equals 51. Now when we add them, we get 7x equals 51 minus 16 is 35. That means x equals a 5. Glad these are coming out to be nice. So now we take this 5 and stick it right back up here, either equation for x, and we get something like 3 times 5 minus y equals 17. Subtract 15 from both sides and you get minus y equals 2. Divide by a negative 1, y equals a negative 2. So 5, negative 2. Let's double check and make sure that works. Negative 2 times 5 is negative 10, plus 3 times negative 2 is a negative 6. Negative 10 plus negative 6 is indeed negative 16. Cool. All right, last one. Number 18. Oh, 4x plus 6y equals 26, 3x plus 5y equals 20. Ew. In order to get these x's gone, we'd have to make these both like a 12 and a negative 12, or make these a plus and minus 30. Let's go for the x's. So let's times the top one by a negative 3 and the bottom one by a positive 4. And let's see what we get. Negative 12x minus 18y equals, what is that? Negative 78. Double check on that. 3 times 20 is 60. 3 times 6 is 18. Yeah, negative 78. Now the bottom one by 4 gives us a 12x plus 20y equals 80. So when we add them, the x's go away, cancel. Negative 18 plus 20 is a positive 2y equals 2. Really? Y equals 1? Out of all that work, y is 1? All right, let's stick them back in and see what we get. If y is 1, we get 3x plus 5 times 1 equals 20. Subtract 5 from both sides, we get 3x equals 15, and x equals a 5. So we get 5, 1 is our point. Let's see if it works up here. 4 times 5 plus 6 times 1, 20 plus 6 is 26, and it works in both of them. Excellent.